To the data structure tutorial, and today we will be discussing about linked list. And before starting to the linked list, we must understand why to use linked list. That's why I have mentioned some points here. So because there are some disadvantages of array, as I have mentioned here, that size of the array must be known in advance before using it into the program. So let's say we have this array. So whenever you want to use array, you have to declare the size of array. For this example, suppose we have an array and whose declared size is suppose 4. So you have to mention this size 4. You cannot change this size later on while running your program. So that is the second point. It is almost impossible to expand the size of array at runtime. Means once you declare the size of array, that is 4 in this case, you will not able to make it 5, 6, 7. Okay, so it has to be declared earlier and it cannot be changed. In the third point, I have mentioned that all the elements in the array needs to be contiguous stored in the memory. So what it means, so if you are declaring these variables in the array, so that will be maintained under certain index. So 0, 1, 2, 3 are the index numbers which we generally keep, and whatever data you will put, for example, you are putting the data A, B, C, D, this is the data which I have put. Now this should be in the sequence. So whatever memory allocation will be for this particular element, let's say that if we have allocation, suppose we have a memory address for this first element is suppose 100, then for integer we are required 4 bytes, so automatically the memory required for the second element will be 104. Here the memory location for the third element will be suppose 108, and for the fourth location will be 112, because each uh, memory is required 4 bytes. We are considering these variables are integer type of variables. So it requires 4 byte each. So all memories should be in the sequential manner. So 100, 104, 108. You cannot keep any random addresses here. So it should be in a sequence only. That is the one of the disadvantage. And the third advantage is disadvantage is, like if you want to delete particular element, suppose you want to delete this C. So what you need to do, by the definition of the array, it should be contiguous memory. So after 104, your next element should be at 108. So you cannot jump from 104 to 112. So you have to shift this last element to the position which is in the contiguous to the next element, the previous element, that is 104. So you have to shift this D to this location. Okay, so it looks that additional operation for us. Now let us imagine that suppose you have a size of your array is 1000 elements. Suppose this is 999. So you have total 1000 elements, and you deleted this element which is from the second index. So what you need to do, you have to shift all the remaining 997 elements to the particular location. So next element will be shifted, next element will be shifted. So those all are the additional operations for us, right? When it has to do, whenever you are deleting the element, you have to shift all the remaining elements to that position. So that is an additional operation and it will increase your complexity of your program. Now same way, if you want to add the new element, so suppose we have a C and in between somewhere here you want to add the another element, suppose P. So what you need to do, you need to shift C here, you need to shift D here, you need to shift next element, next element, next element. Now suppose your array is completely filled, where you will shift this last element, because you cannot change the size. So that is the one thing. And suppose if you want to keep some additional size, then additional declaration should be there. So instead of 4 of size, you will declare array of certain size, suppose 2000. Then only you can have the additional space and you can use that. So that is a last point which I have mentioned, that insertion and deletion in any element in the array needs shifting of all the predecessors. Means you need to shift all the operation elements to a particular location when you decided to insert or delete the element from the array. So by considering these all limitations, there is a concept of linked list introduced. So the very first point of the linked list is it is a dynamic memory allocation. So what is meant by dynamic memory allocation? So here in the array, once you declare the size, you will get that much memory blocks for your data. But whenever we talk about the dynamic memory allocation, so it will create a memory for your data as per the size of your data. So the structure of that memory allocation in the linked list, we have to consider this block. We'll call this block as a node. So how this block will be designed, we'll be discussing in the coming series. But as of now, you have to just think on that. We have a memory block which will give us two different blocks. And in the first block, you will store your data. Let's say that data is A. This is your data which you have stored. Okay. And I'll name this as your data or the information. And the second field which will be called as the address of the next memory location. So I'll name this as address. Second block will be an address of next memory location. So it is also, linked list is also a sequential collection of the elements. Okay, but not the contiguous memory. So second point, I have mentioned that all the nodes of the linked list are not contiguous. It means that not continue memories. Those memories can be random. So when you create this block, the next block will be, suppose we do not have any additional block, so I'll mark this as a null. So we do not have any additional address, so I'll mark it as a null. And linked list is kind of blocks. These are the different blocks and you need to connect them. So let's say I'll consider one linked list here. So this is my list with certain data A, B and C. Every block has certain data. Okay. And by the definition of linked list, this block, the second block, should contain the address of next information. So what I'll do, and as it is a dynamic memory allocation, so every block will get a dynamic memory which is not in the sequence. It will get any memory. So I'll keep a random addresses. For example, 850 is the address of this block, 720 is the address of second block, and for the third block the address is suppose 900. You can keep any addresses. It doesn't matter because that will be allocated by your functions, and memory can be anything. Okay, so what we want to do, we want to maintain the sequence. So what you will do, you will visit this block A, and after A you want to visit. So where is the B? It is at 320 address. So what you will do, in the second block you will write that address 320. It means that after A, if you go to the location 320, you will get your another information, and here if you mention 900, so you will get another information. And after C there is a no element, so in the last block you will be writing null. So means there is a no further element you can visit after C. Okay, so this is nothing but your linked list. You are linking the different data or the different blocks or the nodes and creating a list. So size is no longer problem, since we do not need to define its size at the time of declaration. So you can see that we have not mentioned somewhere that I have only 3 blocks or the 4 blocks. Now let's say I want to add additional block inside this. I want to create a additional block inside this. So how will you create it? Now this is the additional block which will be creating. Let's say this block is dynamically generated, memory will be allocated, and it has a certain address. Suppose that address is 500. And you want to store certain information, so I'll provide certain information, for example D. And the next block is null. We do not have any information into it, so we'll keep it as null. Now you want to add this information in between somewhere. So we have seen that if you want to add into the array, you need to shift the remaining elements, and that is an additional operation. So here we do not need to do that. We have to just make some small changes. So I want to insert this node in between somewhere this. So what I want, after A I should visit B, and after B I want to go to the D. Now what is the address of D? It is 500. So this next block, the address block of the node B, should contain the address of D. So instead of 900 we have to write 500 here. So what it means? It means that it will be coming to this address. Okay, so after A you can visit B, after B you can visit D, and after D again you want to come to the C. So what you will do, you will write here in the address block, you will be writing 900. So this block will be connected to the last node, that is C, with address of 900. So you can see that with only two changes, one is the address of in the block of this B address 500, and here by making these two changes you have added the additional information into your existing list. So A, B, D and C. So it is not creating an additional operations, means it is less as compared to the array. So that is an advantage. Same way, suppose if you want to delete an element, suppose you want to delete this node. So what you need to do, after A you want to go to directly D. So this is the address after A to which you are visiting. So now you want to visit directly 500. So what you will do, instead of 320, you will write I want to go to the 500. So it will not go to the 320, it will directly go to the 500, and this B should not go to the 500, it should go to the null. So you will removing this, so you will be going to the null. So automatically after A you will go to the 500, and after 500 you will go to the 900. So you will go to the C. So this, in this way your list is growing and shrinking as per your requirement. If you are adding the node, the list will be increased. If you are deleting the node, list will be shrinking automatically. So you are making the use of memory very efficiently, and that's why we need a linked list, because it will provide you the facility of use of dynamic memory allocation and utilization of memory as per your programs. So there are two different types of the linked list. One is, the first is singly linked list. Singly linked list, you can see that you can go to the A to the D or A to the B, but you cannot traverse back. So it's a one directional chain. So that is a singly linked list. And if you want to traverse in a both way, forward and reverse, so we will be studying doubly linked list. So these are the different types of the linked list which we'll be discussing in the next video.